Hi guys, I'm preparing this video for you today because I cannot be here. You're going to have to excuse the fact that it's very unprofessional and it's not real special, but here we go. So today we are going to go on a lesson that is something we have to do before we get to more complicated equations. We've been solving two-step equations, but we're going to step back from that right now. And we're going to do something that's called simplifying like terms. So in your notebooks, put a title that says simplifying like terms. All right. So we've done this a little bit in the past, but we're going to go forward. We're going to talk about what is a like term. Well, like terms are alike, go figure. But they're alike when they have the exact same variable. And the variable has to be exactly the same, including the exponent. So looking at this first example, we have a bunch of terms here. 4a is a term, 7 is a term, negative 10a is a term, and negative 10 is a term, and 6x is a term. Let's look at the ones that are alike. I use symbols around terms to help me figure that out. So let's start with 4a. I'm going to put a little diamond, a triangle around 10a. 10a is a term. 7 is not like 4a because 7 doesn't have an a, so it's not like it. So let's go to the next term. Negative 10a. Well, wait a minute, it's got an A. This one has an A. They're like terms. And it's negative, so I'm going to triangle that in. We go to negative 10. Negative 10 is not like any of those A's, so skip it. 6x, it's not like that A. Skip it. Well, let's now look at 7. 7 is a term. I'm going to circle it. Let's see if there are any other terms like 7. Well, that's not like 7. We already talked about that. Negative 10. Well, wait a minute. Negative 10 does not have a variable. 7 does not have a variable. So negative 10 is like 7. 6x. Okay. Let's box 6x. That's a new, different kind of term. And it's not like any of the others. So there you see those are the like terms. 4a is like negative 10a, 7 is like negative 10, and 6x isn't like any of them. Coming down here and looking at these. Okay, 5x, ooh, that's an x. Let's circle it. Let's go to x squared. Wait a minute. X squared has the exponent 2. It's not like x, because it's got a 2 that has a 1 that we don't usually write, but so that's not like that. 3, oh, it has no variable at all. It's not like either one of those. Negative 2x. Well, wait a minute. Let me change pencils here. Let's do a triangle around that. X squared, not like that. Ooh, it's like that. Ooh, big old triangle. And then let's come back and say 3 is all by itself. So there we have like terms. All right. So let's combine like terms. So in your notes, we're going to actually combine. And combine, we don't like to say that we're going to add them because sometimes they're negative, so we're not adding them, we're combining them. But let's start off by identifying the like terms. 5a. Well, let's see what's like 5a. Is 2 like 5a? No, because it doesn't have an a. Is negative 3a like 5a? Well, yeah, they might have different coefficients here, but they have the same exact variable, so they're alike. And then we have negative 7. Not like an a. 2. 2 is a positive 2. Well, it's not like those, but it is like this negative 7. So now let's do the work of combining. 5a and negative 3a. If I combine those, 5a and negative 3a, I get 2a. Now let's look at these two. We have 2, I'm going to put plus because there's a plus there, 2 and negative 7. Let's combine these two because they are like terms, and I get negative 5. So that's an example of a basic, simple little problem combining like terms. Sometimes, though, we have to deal with the distributive property first. Remember distributive property? That's when we multiply against a quantities that looks something like that. Here is example 2. So we have 6x plus 8 plus 3 times the quantity, 4 plus 2x. You can't add 8 to 3 because there's a multiply that needs to happen first. Remember, Aunt Sally says we multiply before we do anything else. So first we have to distribute. So first we're going to distribute. We're going to say 3 times 4. What's 3 times 4? Well, shoot. Oh, change pens. 3 times 4, that's 12. And then we're going to say 3 times 2x, and that's a positive 2x. That's plus 6x. And then I'm going to come back and just write down all these terms. 6x plus 8 plus all that. And now it's just a string of numbers, so let's go and identify like terms. 6x, is it like 8? No, they don't have the same variable. Is it like 12? No, they don't have the same variable. Is it like the 6x? Yes, as a matter of fact, it's just like that 6x. All right, 8. Let's make a little triangle around that one. It's not like that. Is 8 like 12? Yes, it is. They share the same variable, as that is to say they have no variable at all, so they're alike. So now I'm going to combine 6x plus this 6x plus the 8, and these are all positive, plus the 12. Now I'm going to combine these two, which gives me 12x, and then I'm going to combine these two, which gives me 20. And I am done. D-U-N, because 12x is not like 20, so I cannot combine them. And that's pretty much it. So as you do your worksheet today, remember, combine the like terms, but distribute first if you need to. Thanks a lot, y'all. Bye.